In the heart of a distant nebula, a star 100 times the mass of our sun is dying. It collapses under its own immense gravity and then erupts in a supernova, an explosion so violent it unleashes more energy in a single moment than our sun will in its entire 10 billion year life. It is an event of unimaginable, cosmos-shattering power, and yet it makes no sound. In our cinematic dreams, space is a battlefield of roaring engines and thunderous explosions. But the reality is a far deeper, more profound truth. The universe, for all its fire and fury, for all its creation and cataclysm, is wrapped in a blanket of absolute, unbroken silence. Why is a place of such magnificent violence so quiet? Tonight, we embark on a journey not into the light, but into the silence. We will explore the very nature of sound, why the void between worlds is its eternal enemy, and how we have learned to listen to the cosmos using senses other than our ears. Prepare yourselves for a meditative voyage into the great, still vacuum. We are going to explore one of the most overlooked yet fundamental features of reality, the profound silence of space. Before we can comprehend the great silence, we must first understand the symphony. We are born into a world of sound. It is the first sense that connects us to the outside world, the muffled beat of a mother's heart in the womb. Our planet is a musical instrument of continental scale. It is the roar of a waterfall, the whisper of wind through a forest, the rhythmic crash of ocean waves upon a shore, the complex and beautiful cacophony of a city. Sound is the texture of our reality, the invisible architecture of our daily lives. But what is it? What is this invisible force that can convey joy, fear, and sublime beauty? Sound is not a thing in and of itself. It is a disturbance. It is a story being passed through a crowd. It is, in its purest form, a vibration. Imagine striking a bell. The metal of the bell shudders, vibrating back and forth with incredible speed. As it pushes outwards, it compresses the air molecules next to it, packing them tightly together. As it pulls back, it leaves a space, a region of lower pressure. This single push and pull creates a wave of high and low pressure, a vibration that begins to travel outwards through the air. This is a sound wave. The analogy is a line of dominoes. The first domino doesn't travel to the end of the line. It simply tips over and transfers its energy to the next domino, which transfers its energy to the next, and so on. A wave of motion travels down the line, but each individual domino barely moves. The molecules in the air are those dominoes. When you speak, your vocal cords vibrate, starting a chain reaction, a pressure wave that travels through the air, jostling a chain of countless molecules, until it reaches the delicate membrane of an eardrum, which in turn vibrates, translating that physical motion into the electrical language of the brain. Sound needs a medium. It needs a chain of dominoes. It needs something to carry its message. On Earth, that medium is most often the air, a dense ocean of nitrogen and oxygen containing roughly 25 quintillion molecules in every cubic centimeter. This dense crowd of particles is perfect for transmitting the vibrations of sound, allowing it to travel at a brisk 767 miles per hour. Sound can also travel through water, even more effectively, in fact, and through solid ground. Every sound you have ever heard, from the softest whisper to the most deafening thunder, has been a physical, tangible wave of pressure, a vibration carried to you through the matter of our world. It is the fundamental law of acoustics. Sound requires substance. And this single, simple law is the reason why the cosmos, the grandest stage of all, is a silent theater. To understand this, we must now leave our dense, noisy ocean of air and travel into the great emptiness. We now leave the familiar shores of Earth's atmosphere and venture into the void, the space between the planets, between the stars, between the galaxies. We call it a vacuum. The word itself conjures images of perfect, absolute nothingness, an infinite expanse, utterly devoid of matter. But this, like the permanence of the stars, is another of the cosmos's great illusions. Space is not truly empty. It is just the closest thing to it. The interstellar medium, the space between the stars and our own Milky Way, is populated with a thin, tenuous soup of gas atoms, mostly hydrogen and helium, along with tiny grains of dust. But the key is its density. Where the air in your room contains quintillions of particles per cubic centimeter, the vacuum of interstellar space contains, on average, just one single atom per cubic centimeter. Let us return to our analogy of communication. Trying to create a sound wave on Earth is like whispering a secret in a packed concert hall. You tell the person next to you, they tell the person next to them, and the message spreads rapidly through the dense crowd. Now imagine trying to do the same thing in the middle of the Sahara Desert. The nearest person is a mile away. You can shout as loud as you want, but there is no one there to receive your message, no one to pass it along. The story dies with you. The vacuum of space is that desert. The individual atoms are the people, separated by distances so vast they almost never interact. If you could somehow strike a colossal bell in the middle of interstellar space, the metal would still vibrate. It would still try to push against the particles around it. But with only one atom in a space the size of a sugar cube, there is no chain of dominoes to knock over. There is no crowd to carry the message. The vibration has no medium. The sound is still born, a silent scream into an abyss that cannot hear it. The emptiness is difficult to comprehend on a human scale. A laboratory on Earth can create what we call an ultra-high vacuum, a chamber from which we have pumped out almost all the air. The best of these chambers can get down to 1 trillion molecules per cubic centimeter. We consider this a near-perfect vacuum. But even that is 1 trillion times denser than the space between the stars, and the space between the galaxies, the great intergalactic void, is even emptier still, with as little as 1 atom for every cubic meter of space. This near-total lack of a medium is the great silencer of the cosmos. It is the fundamental physical barrier that separates the events of the universe from the sound of those events. And nowhere is this barrier more profound than when we consider the most violent and what should be the loudest object in our own solar system, our sun. We have spent the last century building colossal ears, radio telescopes, dishes the size of valleys, scanning the heavens, listening for a single anomalous signal, a whisper of intelligent communication from another world. We have learned to read the language of light, to interpret the song of space-time. Our ability to listen to the cosmos has become exquisitely sensitive, and in all that time, from all those billions of stars and galaxies, we have heard nothing. The universe is silent. This profound cosmic quiet is the heart of one of the most troubling and fascinating paradoxes in science. The Fermi paradox, named for the physicist Enrico Fermi. It asks a simple question. Given the vast number of stars and planets in our galaxy, and the high probability that some of them should harbor life, and the vast amount of time that life has had to develop, why have we found no evidence of it? Where is everybody? The silence we have been exploring may not just be a matter of physics, it may be a message in and of itself. This idea is encapsulated in a concept known as the Great Filter. The theory suggests that somewhere along the path from simple life to a galaxy-spanning technological civilization, there is a barrier, a filter, that is incredibly difficult or impossible to overcome. The universe is silent because no one, or almost no one, makes it past this filter. What could this filter be? There are many unsettling possibilities. Perhaps the filter is behind us. Perhaps the initial spark of life itself is an astronomically rare event, and we are one of the first, if not the only, living worlds in our galaxy. In this case, the universe is silent because we are alone. Or perhaps the filter is ahead of us. Perhaps it is common for life to evolve, and even for intelligence to emerge. But perhaps technological civilizations invariably destroy themselves before they can ever reach the stars. Through nuclear war, environmental collapse, or some unforeseen consequence of their own technology, they fall silent. The silence, in this scenario, is a graveyard. It is the sound of failed civilizations. There are other, more exotic possibilities. Perhaps advanced civilizations have no interest in communicating. Perhaps they use a technology we cannot yet comprehend. Or perhaps, in a darker turn, there is a predator in the cosmos, and the smart civilizations are the ones who know to stay quiet. The silence is a dark forest, and no one dares to light a fire. The great silence remains the most profound mystery of all. It transforms the quiet of space from a simple physical fact into a deep existential question. When we listen to the void, we are listening for an echo of ourselves, and the fact that we hear nothing forces us to look back at our own world, at our own noisy, fragile, perhaps impossibly rare civilization, and wonder about our own chances of surviving long enough to one day break the great cosmic silence. Our journey is at its end. We have traveled from the simple physics of a vibrating string to the complex psychology of the human mind in orbit. We have learned that the silence of space is not an oversight of nature, but a fundamental rule, born from the vast emptiness between the stars. We have discovered that the universe was not always silent, that it was born in a sonic fire, the echoes of which we can still detect today. We have seen how our own ingenuity has allowed us to cheat the silence, to speak across the void with the language of light, and to listen to the secret whispers of space-time itself. We return now to where we started, with the idea of a silent cosmic cataclysm. But the silence no longer feels like an absence. It is not an emptiness. It is a presence. It is the canvas upon which the universe paints its masterpieces. Without the silence, we could not see the light. The quiet of the void is the necessary backdrop for the story of the cosmos to unfold. It is the silence that makes the light of a distant galaxy precious. It is the silence that makes the faint whisper of a gravitational wave a profound revelation. It is the silence that forces astronauts to see our world in a new unified way. And it is the silence that presents us with the ultimate mystery of our own existence. The next time you look up at the night sky, listen. Do not listen with your ears, but with your mind. Listen to the perfect quiet between the stars, and in that quiet, remember the profound truth of your own world. A world filled with the sound of wind, of water, of music, of laughter. A tiny, noisy, miraculous exception in a universe that is, for the most part, majestically, beautifully, and perfectly silent. The silence is not something to be feared. It is something to be understood. For in embracing the great cosmic quiet, we learn to truly appreciate the symphony of home. Our sun is the heart of our solar system, a colossal sphere of plasma, 1,000,000 miles across, a churning, raging inferno of thermonuclear fusion. At its core, the pressures are 250 billion times greater than on Earth, and the temperature reaches 27 million degrees Fahrenheit. Every second, it fuses 600 million tons of hydrogen into helium, unleashing an energy equivalent to the explosion of trillions of nuclear bombs. It is a place of continuous, unimaginable violence, and it should be deafening. The surface of the sun is a roiling, boiling sea of plasma. Convection cells the size of Texas rise and fall, creating a deep, resonant hum. Powerful magnetic fields, twisted into knots by the sun's rotation, snap and reconnect, unleashing solar flares, titanic explosions that fling billions of tons of material into space at millions of miles per hour. These events are acoustic nightmares. Scientists who study the sun, through a field called helioseismology, can observe the vibrations on its surface. They have translated these vibrations into sound, and the result is a terrifying, deep, roaring noise, a cosmic symphony of pure power. The sun is, by any measure, the loudest object in our solar system. The sound waves generated by its turbulent surface are millions of times more powerful than any sound ever produced on Earth. They are waves of pressure so intense they would instantly vaporize any object they encountered. The sun is, quite literally, screaming. And yet, we hear none of it. We are separated from this inferno by 93 million miles of the thing sound cannot cross, the vacuum of space. The analogy is a magnificent orchestra playing inside a perfectly constructed, perfectly soundproofed concert hall. Through the thick, triple-paned glass windows, you can see everything. You can see the fury of the conductor, the frantic motion of the violin bows, the powerful blasts of the brass section. You can see the cymbals crash together in a silent explosion of light. You witness all the drama, all the power, all the passion of the performance, but you cannot hear a single solitary note. The sound is trapped, contained by the barrier that separates you from it. We on Earth are the audience outside that concert hall. The 93 million miles of vacuum between us and the sun is the perfect soundproofing. We can see the light of the solar flares. We can feel the warmth of its radiation. We can even be struck by the charged particles of its solar wind. We can witness every aspect of its violent performance. But the sound, the incredible, world-shattering roar of our own star, is lost forever to the void. It is a song that will never reach an audience. This silence of the present-day universe feels absolute, eternal. But it was not always so. In the very beginning, in the first moments of creation, the cosmos was a very different place. A place where sound was not only possible, it was the architect of creation. We now journey back in time, back before the first stars, before the first galaxies, before the silence. We travel to the dawn of the universe, to an era just after the Big Bang, a period known as the acoustic epoch. For the first 380,000 years of its existence, the universe was not a cold, empty void. It was a hot, dense, and opaque fog. Imagine the entire observable universe, all the matter and energy that would one day form trillions of galaxies, compressed into a space not much larger than our own Milky Way. The temperature was thousands of degrees too hot for stable atoms to form. Instead, the cosmos was a seething, primordial soup of subatomic particles, protons, electrons, and photons of light. In this dense, hot plasma, matter and light were locked together in a cosmic dance. The photons were trapped, constantly bouncing off the free electrons, unable to travel any significant distance. The universe was a glowing, opaque fog. And crucially, this primordial soup was dense enough to carry sound. This early universe was not perfectly uniform. There were tiny quantum fluctuations, regions that were infinitesimally denser than others. These dense spots were seeds of gravity, trying to pull more matter in, but the intense radiation of the trapped light pushed back, creating an outward pressure. This cosmic tug-of-war between gravity pulling in and radiation pushing out created colossal oscillations, vast waves of pressure that rippled through the primordial plasma. These were the first sounds in the universe. The analogy is a colossal bell, struck at the moment of creation. The entire cosmos was that bell, and it began to ring with a deep, fundamental tone and a series of complex, higher-pitched overtones. These sound waves were not small. The largest of them were hundreds of thousands of light-years across. For 380,000 years, the universe was filled with this cosmic symphony, this subsonic hum of creation. Then, the universe cooled enough for protons and electrons to combine and form the first stable hydrogen atoms. This event is called recombination. Suddenly, the photons of light were set free. The fog cleared. The universe became transparent for the first time. The sound waves, which needed the dense plasma to travel, were frozen in place. The cosmic bell was muted, but the imprint of those sounds was left behind, frozen into the light that was just released. That light, the afterglow of the Big Bang, is still traveling across the universe today. It has been stretched by the expansion of space. Its high-energy light cooled into the low-energy microwaves we now observe as the cosmic microwave background radiation. When we map this background, we see a pattern of slightly hotter and colder spots. These are the fossilized remnants of those ancient sound waves, the compressed and rarefied regions of the primordial soup, magnified to cosmic proportions. Scientists have been able to analyze these patterns and recreate the sound of the early universe. It is a deep, guttural roar, a sound that drops in pitch as the universe expands and cools. It is the dying echo of the first and greatest sound of all time. But once the silence fell, we needed a new way to listen to the story of the cosmos. With the universe muted, with sound trapped and lost in the expanding void, how do we know anything about the cosmos? How can we tell the story of a supernova or witness the birth of a star if we cannot hear it? We have had to evolve, to develop new senses. For most of human history, our only tool for listening to the silent story of the universe has been our eyes, and the language it is written in is light. Light, or more broadly, electromagnetic radiation, is the universe's primary messenger. Unlike sound, it is not a pressure wave. It is a fundamental particle, the photon, a self-propagating wave of electric and magnetic fields. It requires no medium. It is perfectly at home in the vacuum. It travels at the ultimate cosmic speed limit, 186,000 miles per second, carrying information across the vast silent gulfs between the stars. The analogy is reading a letter from a distant friend. You cannot hear their voice. You cannot hear the emotion or the tone, but the words they have written on the page, the ink they have used, tells you their story. Light is the ink of the universe, and with our telescopes, we are learning to read its letters. The light we see with our eyes is just a tiny fraction of the full message. The electromagnetic spectrum is a vast keyboard of information, and visible light is just one single key. By building different kinds of telescopes, we have taught ourselves to see the other invisible notes. Radio waves, the longest and lowest energy waves, reveal the cold, ancient universe. They show us the faint afterglow of the Big Bang, the whisper of cold hydrogen gas between the stars, and the powerful jets of energy being blasted from the hearts of distant galaxies. Infrared light allows us to see through the vast clouds of interstellar dust that would otherwise obscure our view. It is the key that unlocks the secrets of stellar nurseries, allowing us to peer into the dusty cocoons where new stars and planets are being born. It is the language of heat and formation. Ultraviolet and X-ray light reveal the most violent and energetic events in the cosmos. The seething million-degree gas of the sun's corona, the superheated accretion disks of matter swirling around black holes, and the shocked, expanding remnants of supernovae all blaze in this high-energy light. Finally, gamma rays, the most energetic light of all, are the signatures of cosmic annihilation. The collision of neutron stars, the mysterious gamma-ray bursts, and the decay of radioactive elements all scream their stories in this lethal, high-frequency language. By combining these different views, we become fluent in the language of light. We can construct a complete picture of a cosmic event, like a silent film that we can watch in every color, from the lowest radio rumble to the highest gamma-ray shriek. For centuries, this was the only way to listen. But recently, we have discovered a new messenger, a whisper that is not made of light, but of gravity itself. For all its power, light has a fundamental weakness. It can be blocked. A dense cloud of interstellar dust can hide a stellar nursery from view. The sun itself is an opaque ball of plasma. We can never see directly into its core. The universe is full of closed doors, places that the language of light cannot penetrate. But what if there was another messenger, a whisper that could travel from the heart of the most violent and secret events, a message that could not be blocked or absorbed? In the last decade, we have learned to hear it. This is the sound of gravity itself. In 1915, Albert Einstein gave us a new picture of the universe. He told us that space and time are not a static, empty stage on which the universe performs. They are a single, unified entity, space-time. And space-time is not rigid. It is a dynamic, flexible fabric. Massive objects, like stars and planets, create dimples and curves in this fabric. This curvature is what we feel as gravity. But Einstein's theory made another, more profound prediction. It said that when massive objects accelerate, when they move in violent ways, they should create ripples in the fabric of space-time itself. These are gravitational waves. The analogy is a still pond. A massive object, like a star, is a heavy ball resting on the surface, creating a dip. But if two of these massive objects, say two black holes, are orbiting each other, they are like two hands stirring the water. They create waves, ripples of curvature, that spread out across the pond at the speed of light. These are not waves moving through space. They are waves of space itself. For a century, these waves were purely theoretical. They were thought to be so incredibly faint that we could never hope to detect them. The effect of a passing gravitational wave on Earth is to stretch and compress space by a minuscule amount, less than 1/10,000th the diameter of a proton. Detecting such a subtle change is one of the greatest technological challenges in the history of science. But we built an instrument capable of it, the Laser Interferometer Gravitational Wave Observatory, or LIGO. It is the most sensitive listening device ever created. On September 14, 2015, it heard its first whisper. It was the sound of two black holes, each about 30 times the mass of the Sun, colliding in a galaxy over 1 billion light-years away. For a fraction of a second, as they merged, they released more energy in the form of gravitational waves than all the stars in the observable universe combined. LIGO and its partner observatories have since heard dozens of these events. The mergers of black holes, the cataclysmic collisions of neutron stars. We have opened a new window onto the universe. We can now listen to the silent song of space-time. We can hear the events that are hidden behind veils of dust or locked within the hearts of stars. This is a new sense, a new language, and it is teaching us that even in the silent void, the universe is filled with the echoes of its most powerful dramas. We have explored the grand, cosmic reasons for the universe's silence. We have journeyed back to the first sound and forward to the new science of gravitational waves. Now let us bring this concept back to a human scale. Let us place ourselves in the void, on a spacewalk just outside the International Space Station, floating 250 miles above the Earth. Here the silence is personal. It is immediate. You are inside a pressurized suit, a tiny personal bubble of atmosphere in an infinite vacuum. Inside your helmet, you can hear the gentle hum of your life support systems, the crackle of your own breathing, the sound of your own heartbeat. These are the sounds of life, carried by the air inside your suit. But outside that thin visor is a silence more profound than any on Earth. You watch as a fellow astronaut works nearby. You see their arms move. You see their tools turn a bolt. You see the light glint off their helmet, but you hear nothing. It is a silent movie, a human ballet performed in a theater of absolute quiet. If you were to touch helmets, a faint, tinny vibration might pass between you, sound carried through the solid material of your suits. But without that physical connection, there is only the void. So how do we speak? How does Mission Control talk to an astronaut on the moon? How do two spacewalkers coordinate their actions? They must rely on the universe's other great messenger, the language of light. they use radio. A radio works by a simple, elegant act of translation. Inside your helmet, a microphone picks up the sound waves of your voice, the familiar vibrations in the air. The radio's transmitter then converts that sound wave pattern into an electromagnetic wave, a radio wave. The analogy is translating a book from one language into another. Sound is a language that the vacuum of space does not understand, but radio waves are a dialect of the language of light. The vacuum is their native tongue. These radio waves travel out from your antenna at the speed of light, easily crossing the empty space to a receiver on your partner's suit, or on the space station, or all the way down to a tracking station on Earth. The receiver then performs the translation in reverse. It converts the electromagnetic wave back into an electrical signal, which is then used to vibrate a tiny speaker inside the astronaut's earpiece, recreating the original sound wave. The message has been delivered. This process, while routine for us now, is a triumph of human ingenuity. It is our way of cheating the silence. It allows us to carry our most important tool, communication, into an environment that is fundamentally hostile to it. Every word spoken from the moon, every command issued to a Mars rover, every conversation between spacewalkers is a testament to our ability to translate the language of our world into the language of the cosmos. But what about our robotic explorers, who venture to worlds where we cannot yet go? How do they listen to the silence? We have sent our robotic emissaries to the far corners of the solar system. These rovers and landers are our eyes and hands on other worlds. But are they also our ears? How does a machine listen to a world that is, for the most part, silent? They must learn to listen with their bodies, to feel the vibrations of the world around them, and in some rare cases, to strain to hear the whispers in a barely there atmosphere. Let us travel to Mars, to the Perseverance rover. Mars has an atmosphere, but it is incredibly thin, less than 1% the density of Earth's. This means sound has a very difficult time traveling. The Martian air is a poor conductor, a sparse collection of dominoes. Sound on Mars travels slower, is much quieter, and doesn't carry as far. But it is not completely silent. Perseverance carries the first ever working microphones on another planet, and they have captured the first sounds of Mars. They have recorded the gentle, eerie whisper of the Martian wind, a sound that is much softer and more muted than wind on Earth. They have captured the faint, high-pitched zapping sound of the rover's laser as it vaporizes rock for analysis. And they have recorded the clanking, grinding, and crunching sounds of Perseverance's own metal wheels rolling over the red, dusty ground. These are sounds transmitted through the thin air, a testament to the sensitivity of our instruments. But our robots have other ways of listening. They can listen through touch. NASA's InSight lander, also on Mars, was not equipped with a microphone, but with a seismometer, an instrument of incredible sensitivity designed to listen to the heartbeat of the planet itself. Its job was to detect Marsquakes. The analogy is a doctor using a stethoscope to listen to a patient's chest. InSight placed its stethoscope on the Martian surface and listened for the low-frequency vibrations, the sound waves traveling through the solid rock of the planet. And it heard them. It has detected thousands of Marsquakes, the faint tremors of a world that is still geologically alive. It has listened to the rumble of distant meteorites striking the planet. It has even felt the gentle vibrations caused by the Martian wind pressing on its own solar panels. It is building a picture of the planet's interior using a form of acoustic imaging, listening to the echoes from the planet's core. Our rovers are, in essence, deaf in the way we understand hearing, but they are not senseless. They have been designed to interpret the silent language of their environments. They listen to the vibrations in the ground. They feel the pressure of the wind. They analyze the chemical whispers of the soil. They are teaching us that to understand a world, You do not always need to hear its voice. You just need to know how to listen to its silence. We have established the silence of the void as a fundamental rule, but the universe is not entirely a vacuum. The planets themselves are exceptions. Islands of substance with atmospheres of their own. Our rovers have given us a faint taste of the sounds of Mars. But what if we could stand on other worlds, unburdened by a helmet, and listen to the symphony of their alien skies? What would we hear? Science allows us to imagine. Let us return to the crushing, hellish surface of Venus. Its atmosphere is 93 times denser than Earth's, a thick, soupy sea of carbon dioxide. Sound in such a dense medium would behave very differently. The analogy is the difference between speaking in the open air and speaking underwater. Your voice underwater sounds deeper, garbled, and travels much faster. On Venus, sound waves would travel faster than on Earth, but the thick, hot air would likely distort them, robbing them of their high frequencies. The soundscape of Venus would be a deep, oppressive, bass-heavy world. You would hear the constant, low-frequency rumble of the thick atmosphere, a sound not just heard with the ears, but felt in the bones. The distant, continuous thunder from its sulfuric acid clouds would not be a sharp crack, but a deep, rolling boom that seems to come from everywhere at once. It would be the sound of pressure itself. Now let us journey outward to the largest moon of Saturn, Titan. Here we find a world with an atmosphere even denser at the surface than our own, about 1.5 times the pressure, and composed mostly of nitrogen. But the gravity on Titan is only 1/7 that of Earth. This combination of high density and low gravity would create a strange acoustic environment. Sound would travel slower than on Earth. Voices would sound deeper. The air is so thick and the gravity so weak that if you were to attach wings to your arms, you could genuinely fly. The sound of that flight would be a soft, muffled whisper. The soundscape of Titan would be muted, as if the entire world were wrapped in a layer of velvet. Distant cries of its nitrogen geysers or the gentle splash of a methane pebble in one of its liquid ethane seas would be soft, low-pitched, and strangely intimate. And what of the gas giants themselves? If we could somehow survive, suspended in the upper cloud decks of Jupiter, what would we hear? The answer is a symphony of unimaginable violence. We would be in a world of winds that rage at over 400 miles per hour, a constant, deafening roar that would make a terrestrial hurricane sound like a gentle breeze. And then there would be the lightning. Jupiter is home to superbolts. Lightning strikes 1,000 times more powerful than any on Earth. The thunder from these flashes would not be a mere boom. It would be a continuous planet-shaking cataclysm of sound, a crackle and roar of pure elemental power, echoing through the endless hydrogen clouds. Each world sings its own unique, atmospheric song. From the deep rumbles of Venus to the muted whispers of Titan and the deafening fury of Jupiter, the silence of space is punctuated by these isolated pockets of sound. These are acoustic islands in a cosmic ocean of quiet, each with a symphony that is waiting one day for an audience to hear it. But for millennia, before we could even dream of hearing these worlds, we believed the cosmos was already singing a different kind of music. For thousands of years, long before we understood the physics of the vacuum, humanity believed the universe was filled with a sublime and divine music. This was the ancient idea of musica universalis, or the music of the spheres. The Greek philosopher Pythagoras, in the 6th century BC, is said to have proposed that the sun, moon, and planets, as they moved through the heavens, must produce a perfect ethereal harmony. He believed the mathematical ratios in the orbits of these celestial bodies were equivalent to the ratios that create musical scales. The universe, to him, was a grand, cosmic instrument. This idea persisted for centuries. The astronomer Johannes Kepler in the 17th century was obsessed with it. He spent his life trying to decipher the divine geometry of the solar system, to hear the song of God. He assigned musical notes and melodies to each of the known planets, believing their orbital speeds created a celestial choir. To him, the Earth sang the notes melt, F, A. We now know, of course, that this is a beautiful metaphor. The planets do not glide through a physical substance that can carry sound. The celestial choir is a silent one. And yet, were our ancestors entirely wrong? Or were they simply listening for a different kind of music? A harmony written not in sound waves, but in the pure abstract language of mathematics and physics. Today we have found a new way to listen to this silent score. The process is called data sonification. It is a technique where we take streams of data information from the cosmos and translate them into audible sound. We are, in a sense, building the instrument that can finally play Kepler's silent music. Imagine the light from a distant star. As planets orbit, they cause the star's light to dim periodically. We can take this data, the rhythm of the dimming and brightening, and assign it a musical note. The rhythm of orbiting planets becomes a literal rhythm we can hear. We can listen to the music of a distant solar system. Scientists have taken the complex radio signals from Jupiter's magnetosphere and translated them into strange, otherworldly electronic sounds. They have taken the frequency data from the vibrations on our own sun and converted it into a deep, powerful hum. The analogy is a written musical score. A piece by Bach or Beethoven is, on the page, just a collection of ink and lines. It is a silent, mathematical language of harmony and rhythm. It contains all the beauty and emotion of the music, but it is unexpressed. To experience it, you need an orchestra to translate that written language into the physical vibrations of sound. Our computers have become that orchestra. The data we collect from the cosmos is the silent score, filled with the deep, mathematical harmonies of gravity and light. And through sonification, we can finally play it aloud. In doing so, we find that Pythagoras and Kepler were in a way right all along. The universe is filled with music. We just needed to build the right instrument to hear it. We have explored the physics of silence and the ways we have learned to listen to the universe's hidden music. But what is the effect of this profound quiet on the one creature we know of that has actually experienced it directly? What does the silence of space do to the human mind? Astronauts are the pioneers of this new sensory frontier. When they venture outside their spacecraft on a spacewalk, they enter an environment that is the antithesis of human evolution. Our brains are wired for sound. We are constantly processing a symphony of auditory information, the direction of a threat, the tone of a companion's voice, the familiar background noise that tells us we are safe. In the silent void, all of that is stripped away. The experience is often described as both eerie and profoundly peaceful. With the constant noise of the world gone, the senses are heightened. The visual experience becomes all-encompassing. The brightness of the stars, the impossible curve of the earth, the deep, impenetrable black of the void, these things become more real, more vibrant in the absence of sound. The mind, no longer needing to process auditory information, can devote its full attention to the magnificent visual spectacle. This experience is a key component of a profound psychological phenomenon known as the overview effect. It is a cognitive shift, a change in consciousness, reported by many astronauts and cosmonauts during spaceflight. It is the experience of seeing the Earth, not as a map or a globe, but as a small, fragile, living entity, floating in the silent black immensity. The analogy is stepping out of a loud, chaotic, crowded party and into a vast, snow-covered field on a clear winter night. Inside the party, your world is small, defined by the noise and the people immediately around you. But in the quiet of the field, your perspective shatters. The silence forces you to look up. You become aware of the stars, of the scale of the sky, of your own smallness within that grand picture. The trivial concerns of the party fade away, replaced by a sense of awe and connection to something much, much larger. The silence of space is that snow-covered field. It strips away the noise of national borders, of political conflicts, of the daily cacophony of human life. What is left is a singular, silent, beautiful truth, a unified planet, a shared home, without the divisions that are so obvious and loud from the ground. Many astronauts return from their journeys with a deep sense of stewardship for the planet and a newfound understanding of the interconnectedness of humanity. The silence, in this sense, is not an absence. It is a presence. It is a canvas that allows the true picture of our world to be seen more clearly. It is a quiet teacher, offering a lesson in perspective that can only be learned by leaving the noise of our world behind. But this quiet also raises a deeper, more unsettling question. We have learned to listen so intently. Why is our neighborhood of the universe so quiet?